All right, I forgot to record it at the beginning. I meant to record this, but I'll just stick it right here so you can just kind of find the steps. Identify the triangles right here. I set up my proportions right here. Okay, I went 18 to 12 equals x plus 3 to x minus 1. Simplified the 18 over 12 to 3 over 2 just to make it a little easier for us. I cross multiply and then do all the math. I get x equals 9. Plug it back in. Once I get x, I plug it in for this, x plus 3, and I get 12, and I plug it back into here, and I get 8. All right, so there it is. All right, let's do the next one. The next one was probably the hardest out of the whole entire quiz, okay, because there's a little bit of a trick to it. But it's not a trick that we hadn't talked about. It's one that we have done together in class probably a couple times. So that kind of looks like this. But this was definitely a little bit harder than what the first one was. Right there, it looks good. All right, this is parallel. This is 6 and 8. This one is x plus 3. And really the math isn't really more difficult, it's just setting it up. There's just one little thing that you have to realize setting it up. All right, let's put the letters in here. That's P, T, and Q. And then S and R. That's S and that's R. Okay. It says identify the triangles first. Identify the similar triangles. So you had to figure out what triangles were similar to each other. Well, these are overlapping triangles. If you wanted to, you could have separated them. That might have been helpful to you if you wanted to. I'm not going to do that right now, but if you want to, you could separate it. You've got this little triangle. What's this little triangle? P what? TS. Okay, then you got the whole big triangle, which is what? P, Q, R. All right, if you're not sure which letters match up with what, I mean, this one's a little bit easier than the other one to figure out which ones correspond, aren't they? Because look, they both share the P, don't they? Both triangles share that angle right there. Now, these are parallel lines, so that means that these two angles are equal. They're called corresponding angles. They're equal to each other. And that means these angles right here are equal to each other. We've done this problem a couple times together in class. So they are similar triangles. But you got to realize there's two triangles. There's the little triangle, and then there's the whole big triangle right here. All right? Again, if you want to separate them, it might make things just a little bit easier to see. All right, so let's write down our similar triangles. What do we call this? PTS. All right. And again, you could have called this any version of P, T, and S, right? I could have used any combination of those three letters. But it's the other triangle that has to match up with the first one. So what angle matches up with P in the big triangle? Well, P does, right? Because it's the same exact spot. It's the same exact angle. So the P goes with the P. Which one goes with the T? This little angle right here. It's the Q, right? Because they're equal to each other, right? So that's the Q. And what angle goes with the S? What's equal to the S? The R is. So it's got to be PQR. So that's your similar triangles right there. Now what you had to do is you had to solve for PS and PR. PS and PR. So it said find the measure of these two things right here. Find what they're equal to. Find what PS is equal to. Well, PS is this x plus 3, and PR is the whole entire big side right here, isn't it? It's the whole thing. It's not just SR. They're asking for PS and PR. Okay? So how do we do that? Let's set a proportion, right? Let's do the 6 and the 8. All right, let's compare 6 to 8. Now watch what this is, though. You got to be careful with this. This is the entire side. We'll call it the right side. Is that right? We'll call this the left side, the right side, and the bottom of this triangle, even though it's slanted a little bit. All right, so this is the right side of the little triangle. This is the entire right side of the big triangle. So I'm comparing entire sides. I'm not comparing segments of a side. Hear what I just said? That's very important. You may not caught it. I'm not comparing segments to a side. I'm comparing the entire side of each triangle. Some of you see it now, right? So watch. I go 6 to 8. Now, I'm going to compare this. Now, this is what a lot of you guys did. A lot of you guys compared x plus 3 to x minus 1. But is x minus 1 the entire side of the big triangle? It's not. Now I can put an x plus 3 here because that is the entire side of this little triangle. But I cannot compare it to x minus 1. What do I have to compare it to? The whole entire side. So what's that whole entire side? I add those up. Right, x plus x is 2x. Here's a mistake somebody made on a quiz I saw today. It was the other class, actually. They added up 3 and negative 1 and got negative 4 out of that. Is that what that is? What's positive 3 and negative 1? It's positive 2. Okay? So you got to make sure you add stuff correctly. So now what am I comparing? I'm comparing the bottom of the little triangle to the bottom of the whole big triangle. That right there, that little step right there is what I said was probably the hardest part about doing this problem. Okay? And that was the key. All right. Now, if you wanted to, you could simplify this a little bit. Let's do that. 2 goes into that 3 times. 2 goes into that 4 times. It just makes my math just a little bit easier. It wasn't real hard to begin with, but it makes it a little bit easier. So now let's cross multiply. It's 3 times 2x plus 2. Now again, I know a lot of you guys can do that distributive in your head right now, and that's perfectly fine. I'm just writing down everything so you can see what we're doing. So it's 4 times x plus 3. And now we just do the math and we solve for x. So let's do that quickly. That's going to be 6x plus 6 equals 4x plus 12. Subtract 4x from both sides. That'll give you a 2x. Subtract a 6 from both sides. That'll give you a 6. Divide both sides by 2. That'll give you a 3. It's not my answer, though, is it? This is what they're asking for. So what do? We just plug that number in, right? So let's plug it in for PS. Let's do PS, this right here. So x is 3. What do I do with that? Just add a 3 to it, and I get 6. All right, so PS is equal to 6. Now I got to plug it in for PR. Now PR is that whole entire side, isn't it? And we figured out that whole entire side was 2x plus 3. So let's go 2 times x, which is 3. I'm sorry, I said 2x plus 3, didn't I? 2x plus 2. And then, there we go. So that's 6 plus 2, which is 8. And that's what PR is equal to. PR is equal to 8. So that's my answer right there. Okay? Once you see it done, it makes sense, doesn't it? But the hardest part about this, I know, be honest with me. Who compared x plus 3 to x minus 1? Okay, yeah, it's a common mistake, okay? And that's pretty much what I figured. It's a very common mistake. Now, we do have a problem, and I don't have that on this. I think it was another section. Where what if I told you PT and TQ? Then I could compare, watch this, see the difference? I could compare x plus 3 to that segment, and then I could compare x minus 1 to that segment right there. Because these are not entire sides. This is not an entire side of a triangle. It's a segment of a triangle. All right, that's a different problem. But if I'm comparing this whole entire side to this whole entire side, I have to compare this entire side to this entire side. And it's very important to see the difference. Out of the whole test that you're going to take, I think that's probably the hardest part of the whole entire test. I really do. Okay, I think all the other ones kind of make sense as far as comparing one side to the other. Everything matches up pretty good. I think that's probably about the hardest thing you're going to see on the test. That's my personal opinion. You might have a different opinion on some problems, but I personally think that's probably the hardest part you're going to see on the whole test. So make sure you go over those. I've given you worksheets. I've given you problems from the study guide. I gave you that worksheet that we're going to go over today, that test Form 2C thing, right? I'm going to give you another review thing this week, okay, a little bit later on this week. Every one of those reviews probably has a problem just like this, all right? So you need to make sure that you go through it and you know how to get them right. Okay, enough of that. I think we beat that thing to death, didn't we? All right, number 3. I'll tell you what, let me pause this. I just want to see if I have a problem like this on the test, and I don't think I do. But we'll see. I actually don't have this problem on the test, okay? But it was on the quiz, so let's go over it, though. And we went over a problem almost identical to this either the day before or 2 days before we took this quiz, okay? And I even said when we went over it, make sure that you know what we just did right here because you might see it again. And sure enough, you saw it when we took the quiz. So let's take a look. It says a lighthouse casts a 128-foot shadow. All right, well, let's think about what's going on. There's the ground. There's the lighthouse right there. Okay, scooch it right there. And it casts a shadow along the ground, right? So shadows always go along the ground. Would you agree? All right, so it casts a shadow. We'll say the shadow goes all the way to here. All right, probably a little bit long. Sun's a little low in the sky, and the shadow comes all the way to here. Now it says a nearby lamp post that measures 5 feet 3 inches casts an 8-foot shadow. Now this problem doesn't say it, but the one that we did together, it says the shadows end at the same point. Okay, so you kind of have to actually assume that. Tell you what, let's do this. Let's draw a line from here to here, and then there's a lamp post. And the problem that we did together, wasn't his name like Fred or Joe or Bob or something like that? I don't know. I forget what his name was. Anyway, there's the lamp post. All right, there's a big tall lighthouse. This is a lamp post. They both cast a shadow because the sun's right here. It's cast, you know, the sun rays are coming here. The sun's coming down like that, right? That's the ray of the sun. And then this is the shadow cast along the ground. This is the shadow right here cast by the lamp post. And this whole thing right here is the shadow cast by the lighthouse. Does that make sense? Okay, you understand why this line's right here? Because the sun's out here like this, and it's shining down, and the sun's coming down at an angle and creates a shadow. We all understand that, right? We've all seen our shadow before, right? Okay. Let's put some numbers in here. It says the shadow is the lighthouse casts 128-foot shadow. So that means this whole thing is 128 feet. That's the shadow cast by the lighthouse. Then it says the lamppost measures 5 feet 3 inches. Well, we did this the other day on this problem. It says 5 feet 3 inches. This is not, listen, inches is out of, how many inches in a foot? 12, okay? This is not a decimal. I had several people put 5.3. This is not 5.3. 0.3 is in tenths. Inches is in twelfths, isn't it? Okay, it's not in tenths. You can't put 5.3. And Cookie, I see your face. It looks like you did that, okay? But that's okay because you're not alone. You're not the only one that did that. Several other people did that, okay? So you can't put 5.3. You got to figure out what this is, what this decimal is. Well, it's 3 inches out of what? If I want to change this to feet, out of what? Out of 12 inches. 12 inches is a foot, right? So this is 3 inches out of 12 inches. The inches canceled. What's 3 over 12? 1 over 4. So it's 1/4 of a what? Foot. If you want a decimal, yeah, you guys like decimals, so put 5.25. And that's 5.25 feet. And what is that? That's how tall the lamppost is. 5.25. We did that the other day, right before we took the quiz. A day or two before we took the quiz, we did something just like that. Okay? And it casts an 8-foot shadow. So this lamppost casts an 8-foot shadow. So from here to here is 8. All right? What's the height of the lighthouse? We'll just call it X. And now, what do you have? Now, make an assumption that these are both straight up and down, but I think we can assume that. And so they're parallel lines. It looks very close to what we just finished doing, doesn't it? Like number 2. All right, if you look at it, they both share this angle right here. They both have this in common and this in common. These are right angles. Okay? So you have all this stuff right here. You got to make some comparisons, don't you? Let's compare the height to the height. Height of the big one to the height of the little one. So that's going to be X over what? 5.25. Now that's an entire side of a triangle, isn't it? This is the whole left side of that big triangle. This is the whole left side of the little triangle. So I'm going to have to compare it to what? The whole bottom of the big triangle. What's the entire bottom of the big triangle? It's 128. And I have to compare that to the entire bottom of the little triangle, which is 8. We're running out of time. I'll let you do the math on that. You cross multiply and you solve for X and you're good to go. All right? And you should get exactly 84 feet. No decimals or anything. I think it comes out exactly 84. All right? Okay, let's do 4 and 5. Now 4 and 5, most of you got. I don't want to spend too much time on this. Oh, this is one of the easiest ones you're going to do on the whole entire thing. I promise you. Let me show you. Let me put that up here like that. Goes like that, goes like that. Now let me just refresh your memory a little bit on this theorem. If you have, these are parallel lines, okay? Here's your situation. If you have three parallel lines cut by transversals, and if this segment is equal to this segment, what do you think might be true over here? Then this segment is going to be equal to this segment. They're in proportion, basically. They're in a 1-to-1 proportion, right? So if it was given that this one was equal to this one. That was given to us. What can we figure out from that? We can figure out that these two are equal. So really, what is this whole thing about? They put 2x plus 1, they put an x plus 7. So what do we do with those two? We just set them equal to each other. That's it. 2x plus 1 equals x plus 7. There's no real proportions you're doing here. And this was 3y minus 8, and this was y plus 5. And then you set them equal to each other. Again, just for time, I'm not going to do the math. You can do the math yourself, okay? And that's all there is to it. And on number 5, it was pretty much the same thing, okay? It's set up a little bit differently because it's a triangle, but it's the same exact situation. So you just solve for x. X was 6 right here, and if you solve for y, you actually got 13 over 2, but a lot of people like to write it like this. I would accept either way, and that would be your answer. You can do the math on it. That's it. Just set them equal. I had people doing all kinds of crazy stuff. I had somebody, it was the other class, because I just graded the other classes today. Somebody in the other class added these up and set them equal to 180. I don't know why. I mean, because this is the length of a side. This is the length of a side. They just probably saw stuff, and that was just familiar to them, adding stuff up and setting them equal to 180, and so they did. Well, yeah, they learned the wrong way. They learned by getting it wrong. Let me just, real quick, I know the bell's going to ring any second. And so that homework that I gave you on Friday, we're going to go over that tomorrow, okay? I thought I would go over about half of it today, but we'll go over the whole thing tomorrow. I have no idea what the forecast is. Look at this. Look, this is a little different. You don't have 3 parallel lines, but you do have a triangle with 2 parallel lines. But it basically says the same thing. Okay, if this segment is equal to this segment, guess what's true about this one and this one? They're going to be equal too. Now, why is that true? Because they're in proportion. Everybody listening? So if I compare this one to this one, if they're both the same, what's my proportion? What's my ratio? It's 1 to 1, isn't it? So this has to be 1 to 1, which means this segment has to equal this segment. So you do the same exact thing as you did for the other problem. Set these two equal to each other, solve for y, set these two equal to each other, solve for x, and then you've got your answer. Okay, now they did throw a fraction in for x. That might have caused you a little bit of trouble. The y was really easy though. Okay, that was simple to solve for. There's your quiz, okay? You'll see problems like this on the test, so make sure that you're ready for it. I'll go over that worksheet tomorrow, so have it finished, have it ready to go, and we'll go over that thing tomorrow to review.